Now let's do a problem involving the ideas of conservation of momentum and inelastic collisions. So let's consider this example where a baseball player jumps straight up in the air to catch a line drive, and the ball is moving horizontally at something around 28 meters per second, and the catch is made when the ball player is at the highest point of their leap. You want to know what is the speed immediately after stopping the ball. So what we want to do is, of course, as with any of these types of problems, we first draw a picture. Now with momentum equation or momentum problems, we're going to want to draw a before picture and an after picture. So my before picture will look something like I have a baseball player up in the air, and there's baseball, and I'm going to have the baseball moving to the left. Of course, baseball is drastically out of proportion compared to him. So let me say that the initial speed of the baseball is VIB, and the initial speed or velocity of the player is VIP, just to give him some labels. That's our usual thing whenever we're solving a problem. We draw our pictures and then we label everything. So now the baseball player has, after the collision, the baseball player has caught the ball. The baseball player has the ball. And we would expect that the baseball player is going to recoil, or rather go off in this direction, with some final velocity. And that's a common final velocity for both the baseball and the baseball player. So let's list what we have known from what we're given and what we're after to find. So we know the mass of the baseball player, so 71 kilograms. We know the mass of the baseball, that's 140 grams or 0.140 kilograms. And we know the initial velocity of the baseball, and since it's moving to the left, the initial velocity is negative 28 meters per second. The initial velocity of the player is just 0 meters per second. This is the assumption where he's jumping straight up in the air. Straight up in the air, he's not moving horizontally, and he's even not moving vertically, because he's at the highest point of motion. And what we're after, what we want to find, is we want to find this final speed of the baseball player and the baseball after the collision. Okay, so now that we've set up our picture and listed what we know and what we want to find, let's think about how we're going to solve this. Well, I think we're going to use the idea of conservation of momentum. So we're first going to want to find the initial momentum, just multiply the masses and the velocities of everything that we have initially. So the mass of the player times the initial velocity of the player, mass of the ball times the initial velocity of the ball. And since the initial velocity of the player is just 0, this is just the mass of the ball times the initial velocity of the ball. And so multiplying those two numbers together, get negative 3.92 kilogram meters per second. The final momentum is the total mass of both the player and the ball times the final speed. This is what we call an inelastic collision. The two objects have stuck together after the collision. So conservation momentum says that the initial momentum is equal to the final momentum. Or rewriting this in a way that kind of makes it nice to solve for the final velocity, we have that the mass of the person, or the player, plus the mass of the ball times the final velocity is equal to the initial momentum, which is negative 3.92 kilograms meters per second. And so from this we can solve for v sub f by dividing by the sum of the masses, so negative 3.92 kilogram meters per second, divided by mass of the player and mass of the ball. And when we plug in the numbers for the mass of the player and the mass of the ball, we should get a final velocity of negative 0.055 meters per second. Notice that this is to the left, because it's negative. This velocity is negative. And that's exactly what we expected by our diagram, that the final velocity would be to the left. So it's a nice check to make sure that everything, all of our signs were working out. Now we're actually asked for the speed, and so perhaps what we should really do is take the absolute value of this to get the speed. And so the speed of the ball and the player after the collision is a very small 0.55 meters per second.